Hey!
Learn something new today as well.
So I am Steve. You may know me as Scoobs. Passwords. So I'm going to be talking about securing password databases with hardware security modules. Basically, it's a security module. Basically, the way it is so that you're offsetting all of the important things on a specific box that just does securing of data versus having like a IP stack and like OS and all sorts of stuff on there. So that there's not many lines of code that you have to actually secure. So it ends up being more secure because you can't actually like run code on it because it could be like a system on chip or something. So there's these generic, like mysterious HSMs that you can find. I can't really find any exact quotes or anything or what they actually did, but they cost a lot. And they do it wrong, and then some. Since that wasn't a good option for Yubico, they made a one-time password thing. They made the Yubi HSM, which is $500. They actually did a speech. Let's look this up. It was Passwords 11, I think. 10? I didn't actually go there. I wasn't there. I didn't see it, but I saw their slides, and they said to buy two. One to create passwords, and then one to authenticate them. The only thing I could think of is because they're using authenticated encryption associated data, AEAD, the hardware random number generator was slow, so when someone created a new account or changed their password, it might be slow. Only a guess. But anyways, they use AEAD, and if your hash that you're trying to encrypt is only 128 bits, you have to do 5 blocks of AES encryption. And if it's longer than that, so like decrypt, which is 23 bytes, it would be, you'd have to do 7 blocks of AES. It can also do ECD, which I think you can only do one block at a time, so you have to keep pinging it. It's longer. So do we need AEAD? Well, do we have a current ability to tell if hashes are tampered with? No. Someone could change a bit or replace the hash. With AEAD, even though you can tell if like a bit is flipped, you can't actually tell whether someone just created a new one and shoved it in there. So AEAD doesn't really help us. So what do we need? Like the minimum. You can either do it one of two ways. HMAP, which the Yubi HSM I think also does, or CDC null pattern. The reason why, well, the difference between the two. So once someone breaks into your system and grabs your database, there's a time where they're like, oh no, I need the key. So then they could then break in to your data center and steal it and maybe be able to extract the key. So you want to change it over really fast. So you have to tell your users, please sign in so we can change it. But if you encrypt it, you could then have another mode where it just changes the key. So you basically, you give it the old key and the new key and say it's update for the key. So then you just run through all your hashes, re-encrypting them. CDC, the reason why I picked CDC nullpad is you can do whatever other padding schemes you want by just giving them already padded data, or you can do CDC CTS, which is ciphertext stealing. So the encrypted data is the exact same size as the original data, so the hash. and that's basically how you do it. So you, yeah. And then decrypting, you'd have that, you switch them, decrypt that block, which then, since, I should probably go over CBC, which is basically you take the first block and then you XOR it to the second block. So 0 XOR the, actually, where's the, there we go. This part, that is 0 XOR the original part of, so you just take that, and then that's the original first block, then you can decrypt that, and it will give you the original that. So I had this great idea, I should start a company and make a Just Encrypt. It was an awesome name because it just encrypts. And I was like, ooh, $50. And I'm not a corporate guy, so I kind of scrapped that. And it does CBC null pattern, and so it's for 128-bit hash would be 1 block of AES, 256 would be 2 blocks. And then there's this. It's basically just DIY. Actually, I have one. And I got a nice little case for it that I made. Oh, yeah.
What about the? Got it.
Yeah. So you.
Guys at home can say, no, I'm just kidding.
I had to modify the case or whatever. So you can buy one, it's $19 with shipping, and you can buy a micro USB cable. And then, I'm going to open source it once I get back home and get my code, which I don't have with me. Anyway, so this would be an example. If you want to actually back its passwords, or should be at least. So you have, this is decrypt, so that's the beginning part, then that's the salt, and then that's the actual hash. So the only thing that you would encrypt is the actual hash, because if you encrypted the salt or the header or whatever, then you wouldn't be able to generate the actual this hash, then run it through the HSM to get this. It's not really anything. It's kind of anyways, and then that's just an identifier so that you know that it's actually encrypted, and sorry if this is widespread and it works. One more password here is almost. If you have access to, if you have this physical access to the server, you can just pull it out. Well, this specifically is really easy because you probably flash a program on it that dumps the EEPROM, or just access the EEPROM. But even if it is just 140 back to level 4, which is like pressure and like heat and voltage changes that are like clear speeds. I'll show this way. If your data is encrypted with your password, so like, mega, I guess would be an example of that. Then you can just use the data to figure out whether your password is right. Also, if you have root, then you have no rate limit except for how fast you can actually hash and check it with that. And then also you can just change the hashes because this isn't for class. Don't worry, folks, we'll roll their own and fuck it up. You might even forgo hashing because AS256 is fair enough. Thank you. Questions?